Bismillahirrahmanirrahim. So today, inshallah, we will talk about at first electric flux and then followed by Gauss's law. So for that, I will play a video now, and I'm going to share my screen with you. Everyone can see it, right?
Yes.
Okay, so let us start. Couple of minutes are not actually necessary, so that is why I will just fast forward it. He's just introducing the topic, okay? We need to actually see what we mean by electric flux. Yeah, from here we will see. Achha, the lines that he is drawing here is denoting an electric field, E. Okay, an electric field is there and the electric field is passing through a surface. This is a surface, okay? Through this surface, the electric field lines are passing. And the area of this surface he has denoted by A. Okay, so through this surface the electric field lines are passing. What he is saying here is we can actually compare this or consider this or imagine this as a line of water flow. Okay, this is a line of water flow through a pipe. Okay, this one he considered like a pipe. Through the pipe the water is flowing. Okay, so it is something like that. He just gave an analogy, a comparison. Okay, but I think without that you can imagine that some electric lines are passing through a surface. Okay, what he said he will explain it through this page. Okay, see he is holding a page. Okay, so this page will work as a surface now. So he is holding this surface and his hands, the fingers will represent the electric line. So this will pass through this. Okay, the electric lines will pass through this surface. So that is what he is trying to explain. Through the surface it will pass through. Okay, and the surface is perpendicular. See, the way he was holding it, the surface was perpendicular. This is the way, this is the direction of electric field and this is the surface. So the angle between them is 90 degree. Anybody find it difficult to understand that how the angle is 90 degree between the surface and the electric field?
No, sir.
Okay, it is understandable, right? Quite imaginable. Okay, so let's continue. Now, what he's trying to say is, now how the electric flux is going to be, it depends on actually the orientation of the magnetic field lines and the surface. Now here it is, they are perpendicular to each other, right? But it might not be the case always. So that time, how we can calculate? So that one we will see gradually. Now what he's saying is, the way he was holding previously, the maximum amount of electric line was passing through the surface. But what if we keep the same surface in horizontal position? So when the lines will go, many of the lines will actually go above the surface. Many of the line will pass through below the surface, but not actually through the surface. Okay, so in this case the electric flux that we are going to get will be the minimum. Okay, you understand, right? In that case, in the previous case where it was perpendicular to each other, maximum amount of electric lines are passing, but in this case the minimum amount of electric lines will be passing. Okay, through mathematical equation also we will be proving that in this case what happens, they are actually, we get minimum amount of electric flux. So through mathematical equation also we will get to know. Some will go above and some will go below, but not through the surface, not actually through the surface. You can see it is written here. So this case the electric flux is going to be zero. See, the minimum amount, but here it is the maximum amount. It will be as large as it can be. Okay. So these are the two cases. Now he will consider another case where it is neither perpendicular nor parallel. Okay, it a little bit different orientation. He will explain it by drawing the figure on the board first. Okay. I think I should have introduced him first. I don't know his name, but he's a professor from North Carolina State University, USA. Okay. I don't know his name. I should have actually known his name. He explains this very good, I felt. Okay, later we will know. Acha. Now what he is doing, he is drawing the surface on the board, okay? And the surface is not vertical, not horizontal, rather it is a little bit inclined, okay? So he will show that how we are actually considering. See, it is not totally vertical, it is not totally horizontal, but rather it is in between, a little bit inclined. So that time actually area, we will be considering this one as a vector. Okay, see, we will consider a vector which is perpendicular to the surface of the area. See, area of the surface, sorry, this is the surface. So with it perpendicular, we will consider a vector which will be denoted by A. Okay, generally we know that area, it is a scalar quantity, but here we will consider this vector to be area vector. Okay, this is normal. Normal means at a angle of 90 degree with the surface. And the magnitude, okay, whenever we put this absolute value sign, we know that we are talking about magnitude of this vector, and the magnitude will be equal to area of the surface. Okay, there will be a certain area of this surface, so that area will be the magnitude of this vector. And the direction, whenever we talk about the direction of this vector, it will be along the perpendicular direction. See, here he is showing, okay, up page is there. From the page, actually the pen shows that perpendicularly outward is the direction of this vector. Till now, is it clear? I want to make sure that everyone understands.
Sir, আবার repeat করবেন, আমি একটু বুঝি নাই।
আচ্ছা, ঠিক আছে, no problem. Which part, the magnitude part or the direction part?
Magnitude part.
Magnitude, okay. So you can see that we are considering a vector along the perpendicular direction of the surface, right? Here you can see this is the surface. Along perpendicular direction to the surface, we are considering a vector. Now whenever we are talking about a vector, we must specify what is the magnitude of the vector and what is the direction of the vector. So this vector will have a magnitude that is equal to the area of the surface. Okay, whatever the area of the surface is, that will be the magnitude of this vector. And direction, the direction will be perpendicular to the surface. Okay, this is the surface, perpendicular to that, it will be the direction of this vector. Is it clear now, the magnitude and direction? Okay,
Yes.
so let's continue. Yeah, we can change the orientation. Okay, so with the change of the orientation of the page, what will happen, this vector will be changing. Okay, you can see that if we keep this surface at a different position, this will also rotate, right? Okay, if I make it more inclined towards this part, then what will happen, this will also rotate in the same direction by the same angle. This is easily understandable and imaginable, I feel. Now this is just a surface. Now an electric field will be passing through it. An electric field will be passing through it. So you will notice that previously the angle between the electric fields and the surface was 90 degree, right? But now the electric field and this A vector is not having an angle of 90 degree or 0 degree. This is having an angle of something other value, right?
Yes.
Papa, আপনাকে আমি ডাকতে দেখতে যান প্লিজ। ও আয়েন আপনি একটু ওয়াটার খাবার আছে। আচ্ছা থাক থাক, ওখানে স্টার্ট করতেছেন। So electric flux, the symbol for electric flux is phi. Okay, we will put a 0 and put a line through that. That is the symbol. This is the symbol of electric flux, phi. Okay, 0 plus. Now, the definition of electric flux is given in this way. We know what E is, the electric field. We know what A vector represents. The dot product of them is electric flux. Okay, the dot product of the electric field and the area vector is electric flux. Now, dot product means, if you remember, dot product A dot P is equal to AB cos theta. Do you remember this from the vector chapter of internet?
Yes.
So
So it is scalar হবে না?
This is the scalar product. Okay, electric flux, this is a scalar. Okay, whenever we get a scalar product by multiplying two vector, then we call it a dot product or a scalar product. Okay, dot product always produces a scalar. It's going to have units of Newton per coulomb times meter square. Yes, from here actually we can talk about the unit, because this is the this is electric field. The unit is Newton per coulomb. E is equal to F by Q. F is force Newton and Q is coulomb. And then we have area, which is meter square. Anybody have any doubt regarding the unit of electric flux? Newton meter square per coulomb. I hope it is clear. Huh? Okay. Now the value of this electric flux actually will depend on the relative orientation of this surface and the electric field. This is what he is saying. Now how it is affecting the magnitude of electric fields? If I change the angle, this angle, if I change this angle between this E and A, how it is going to affect? Let us see. Now we know, let me explain it on the board, okay? Can you see the board?
Yes.
Okay, till now we got to know that electric flux, which is represented by phi, is the dot product of this electric field and the area vector. Now, if this is the electric field and this is the area vector and the angle between them, let us consider this to be theta. From here, what I can write? E, the magnitude of E into the magnitude of A into cos theta. This is what we know from the dot product, right? If you remember, A dot B was equal to AB cos theta. Now here A is the magnitude of A vector, B is the magnitude of B vector. We can write it with absolute value sign also, no problem. So if I change the orientation of either the magnetic field or the surface, this angle is going to change. If I keep the surface, let us say this is our surface, right? With our surface, the perpendicular vector is A. Now, if I change the orientation of this perpendicular is also going to move, right? As a result, the angle between them, the theta, it is going to change. So if theta is changing, definitely it will affect the product of this two vector, right? So as a result, electric flux will have a different value. Do you understand how the orientation is going to affect the value of electric flux?
Yes.
Okay, thank you. Please. Class আচ্ছা, so let us continue. আরেকটা পেন মার কাছে আছে, যাও যাও। আছে আছে আছে। Okay, sorry for the disturbance. Now let us continue with our video. Did I tell you the name of this alphabet? This is phi, okay? P-H-I, phi. And he's writing the equation that I already explained a little bit ago, okay? And the angle is denoted by theta. From this equation, actually, we will get to know that when the surface is perpendicular, why the electric flux is maximum, and then we will get to know when the surface is horizontal, then why it is electric flux is zero, that is the minimum. Okay, this is what he is explaining, but I think I need to explain it on the board. So for a couple of moments, I will stop sharing the screen. Okay, so kindly take a look at the board. I will be explaining it. We already know ম্যাগনেটটা ছুটে গেছে। How did this happen? নতুন ডাস্টার আনছি স্কুল থেকে, অথচ ছুটে গেছে। ম্যাগনেটটা বোধহয় বেশি স্ট্রং, এর টান মারছে ওখানে ছুটে থেকে গেছে। আচ্ছা যাই হোক, so what I was talking about is, let us say this is our surface. Okay, so when this surface is like this perpendicular, and this is the magnetic field. Okay, so magnetic field is this. Let me represent it on the board like this. Okay, now if the surface is like this, as I'm holding the book, okay, this is the book, so the area, that is the A vector, this is also perpendicular to this, right? So both of them, both E and A, they are parallel to each other. So if they're parallel to each other, then what is the angle between them? What is theta?
180.
180. If they're in the opposite direction,
Zero.
it will be 180, 0 degree. Very good. If they're in the opposite direction, then it will be 180 degree. But if they're in the same direction, then it is 0 degree. So if theta is 0 degree, then phi will be equal to EA cos 0 degree. The value of cos 0 degree is 1. So phi will be equal to EA. This is the maximum value. Why? Because EA is fixed, right? The value that we can change is the angle theta. So when the cos theta will have maximum value, that time only we have the phi will have maximum value. The flux will be maximum. So the maximum value of cos theta can be achieved when the angle is 0. If you remember, you have done this in trigonometry in grade 11. So what is the maximum value of cosine graph? +1, right? And this +1 value, okay, cos 0 degree, this +1 value only can be achieved when the angle between them is 0 degree. Understood? And at 90 degree, cos 90, what is the value of 90 degree? So now let us say
Zero.
I keep the surface like this. I keep the surface like this, so the area vector will be perpendicular from the surface, right? So this is the area vector. Okay, I kept the surface in horizontal. Okay, from here actually the area vector will be acting perpendicular to the upward direction. So this is A. Still, I didn't change the direction of this E. Okay, E is still in that direction. Magnetic field is still in that direction. Sorry, electric field. So what is the angle between E and A now? It is 90 degree, right? So at this point, what is going to happen? Phi will be equal to EA cos 90 degree. The value of cos 90 is 0. So EA into 0 will be equal to 0, right? So see, in this position, this is the area vector. This is the electric field. So electric field and area vector, they are perpendicular to each other. As a result, their product is going to be 0, which will give us the value of electric flux to be 0. Is it clear that in this position, having the
Yes,
electric
sir.
flux minimum 0, and here we are getting the electric flux maximum because the angle between them is 0 degree. Anybody have any doubt?
No, sir.
Okay, alhamdulillah. So let's forward. Let's watch the rest of the part of the video. Sorry. कैमरा दो रहा है. Okay. So he will be actually explaining what I already explained here. The angle 0 degree, that time it will be maximum, and when it is the angle will be 90 degree, that time it will be minimum. So I think we don't have anything else to learn more from this video. So let us take a look at the next video, that is states the Gauss law. Phone becomes very slow. Sorry, the laptop. I guess this is the video. So guys, can we do this? I wanted you to see this video before the class. So as you have already idea about this electric flux, can you watch the rest of the two video that I sent in the group? Okay, then we can discuss about these two videos on Sunday. Can we do this? Tomorrow we will discuss about the vector doubts. Okay, I'm sorry, not the thermodynamics doubts. Okay, so on Sunday, can we discuss about this Gauss law? Will that be okay with you?
Okay, sir.
Okay, so kindly go through the explanation of electric flux that is given in your textbook, okay, and check whether you find any kind of dissimilarity with what we discussed or learned today, okay? And then also try to go through the video of the Gauss law, and then the lines of the textbook or the statement that is given in the textbook, okay? Try to match them up so that it becomes easier for you to understand when I explain it in the next class, inshallah, okay? So kindly message me your doubts from thermodynamics chapter by tonight so that we may have a fruitful class tomorrow on thermodynamics doubts, okay? Many of you have
Sir.
already messaged me. Yes.
Sir, doubt তো অনেক স্যার।
হ্যাঁ, তো কি হইছে? ডাউট অনেক হইলে শিখবা বেশি, এটা তো আনন্দের বিষয়।
I mean স্যার 2 ক্লাসে কভার হবে না।
তো পরে আরো ক্লাস নিব, যত ক্লাস লাগে তত ক্লাস ধরে শিখবো, টেনশনের কি আছে?
না স্যার, আমি বলতেছি যে যদি আমরা ডাউটটা শুরু করি তো একসাথে শুরু করে শেষ করলে তাহলে মাঝখান থেকে গ্যাপ পড়লে।
হ্যাঁ হ্যাঁ হ্যাঁ, সেটা আমিও এগ্রি করি। তো
স্যার
তোমাদের
আমার একটা আইডিয়া আছে কি জানেন, আপনি আসলে কালকে ফার্স্ট পিরিয়ডটা